So we have Chris and then Bastian, but being the moderator, I will just move in before you. Just one very short remark on this. What are the challenges in social systems? You are saying it depends on the mathematics of the applications. In this social science research, we don't even have the mathematics. Chris?
Well, you might have more than you realize if you use networks. But so I think your initial description of HPC considerations, I want to expand maybe the considerations a little bit and just more than simply saying edge computing. And that is, there's this human sensing style function is being handled by us with devices and can legitimately be viewed as a part of the system, and even in some sense inherently computing these changes in the network that you're just talking about, is to say we're doing whatever we're doing and this stuff gets uploaded. It isn't necessarily like you need an explicit modeled representation at a central location. If you arrange it right, you pick up the structure sort of inherently from the broader system, and so that you can naturally exploit to the point of performance. You can naturally exploit parallelism where it occurs, right? I mean, it may be that this little patch of people are interacting, but they're not interacting with this little patch of people over here, and that's just naturally taken up. You don't have to manage that, right? And so you can start to achieve what looks like on a system level extremely high computational levels, right? I mean, this is going to be exascale style computation in its world style computation. That's the first thing. The second thing is, at the moment, I think most of the time when we deal with data, what we're willing to call data, is even human sensor data, the way we use it is we put it somewhere and then we sort of look at it retrospectively. We correlate it or we extrapolate it or something. But just as an example, and there's 1,000 examples of this, if you take this to include decision making, like we've kept saying, and we push decision making down to everybody, like I was talking about yesterday, and so I've made this point before, but I'm just going to make it again because it's pertinent to this. If people are using, for example, simple routing algorithms on a map program, right? And they say, this is where I want to go. Now, I'm not there yet. This is where I want to go. And it produces a route. And there's an option that says, I'm committed to this route. I'm going to do this route. And what you do is uplink all the routes of everybody. Then you could take this data as data and do projective congestion modeling, not retrospective or T-now congestion, but what will be congested if everybody takes these routes, right? And so that you can actually have projective style updates going on in this thing, so it isn't just some sort of like passive update of things. And the coevolution would be the people deciding not to take those routes, for example. So you could imagine enormous levels of computation and inherent algorithms, distributed algorithms being designed into the way these things work, because you could, instead of routing, it could be you intend to buy stocks, or you have a plan for buying stocks, or something. I mean, there's all kinds of projective things that you could imagine putting on the edges that would replace what we currently use HPC for of the current sort of normal variety.
So while Chris was talking, I tried to make my mind, because I have a lot of things to say, but I'm not sure if if I can put this all in the next half hour. No, don't be scared. No. The problem is, I think first of all, I think we have to be careful, because so we started this session when Carlo was giving us the impression also from Moresh Peresh about the exascale strategy, which is a political strategy. I think we have to agree this. Somehow we are in the middle of a race to arms. People want to have the first exascale system, best technology ever. Let's say, working with the technology, we all know that there might be some issues with this technology, because it's not as simple as we had it before when going from teraflop to petaflop, or from, let's say, gigaflop to somewhere else. We are reaching an end of the technology. So one thing is the technology. Okay, nice. Honestly, we could build the exascale system now. It would be not very efficient, but let's say if somebody wants to donate hell of money in terms of energy and, let's say, taking a complete area out and just putting, let's say, servers in there, it would work somehow. I think there's a change in the way we will be able to access the systems, not in terms only of the access itself, but simply, I personally doubt that there will be the same amount of access systems, let's say, in a nearer time span than you would have now with petaflop systems. I think Sanzio gave yesterday a talk about his Marconi machine. So we have, in Europe, if you go there, you have a Cinica machine, Barcelona Supercomputing Center has a machine, Edinburgh Supercomputing Center has a machine, KTH in Sweden has a machine, Germany has even 3 machines, and all love us for that. But the thing is simply, this EXA system will be highly expensive in terms of operation, in terms of maintenance, and we see this already now. There's a big fight in Europe about who gets the money for this, and nobody knows where the money comes from. Nobody really knows what the machine will look like, and nobody really will know how the machine will work. Yeah, we're even talking about a European processor, which is a nice thing. But also here, we have to be realistic. And now this technology has evolved over decades. And the same thing is for the applications which should run on this. Now coming back to the Center of Excellence concept, this is part of, let's say, the whole strategy in Europe. It's like you have PRAISE, which is the entity providing you the access to the resources. You have, let's say, the FET HPC activities, which will provide you, let's say, new paradigms, new algorithms, new approaches towards, let's say, resiliency, fault tolerance, everything here. And you have the Centers of Excellence, which should provide you, at the end, the applications running on this. And here I see a bit of a danger for this community. And you can correct me. I'm always happy if people correct me. What we've seen in the last years now working, let's say, from an HPC perspective with the GSS community is there's a good potential. And there are some people doing, let's say, already, let's say, highly scaling things. But they are, let's say, just a small amount. And if we try to compare ourselves, I'm not saying our means the HPC GSS community, to compare us, for instance, with the climate guys, with the, the energy guys, which are working on this for, as I said, decades. They have still some codes, to be honest, their codes will need a major redo because they're still, let's say, somehow something which started in the 1970s or something like this. But then there's also a danger that we try to force ourselves in a position which we can probably not fulfill that easily, or only partially. So, as I said, the exascale is a bit of a danger because a new community, and I personally see GSS still as or HPC GSS still as a newer community. We're a bit like the aliens. I think Carlo agrees to this. Somehow the people look at us and say, okay, it's nice, but okay, where's your exascale code? But I think the important thing is not to lose, let's say, the traditional life cycle of such a community evolving by forcing by any means to put it in. And I think a good starting point would be probably also to realize what I usually call it the meta simulation approach. I see that applications GSS not necessarily need to scale up to 100,000 of course, but that you might have a workflow of different applications or simulation, which can be from the traditional area like climate, etc., which need to produce the input data that you can take up in your, let's say, small core application on the fly, let's say, going into real-time things, or into real-time area or something like this, whatever real-time means. We can discuss about 1 hour about real-time. But that you rather need these kind of big systems probably to be able to do this in one ecosystem, which is a closed source, coming back to the network thing. I personally doubt that it would be possible like, okay, you have a core GSS application running, let's say in HLRS, and Edinburgh calculates the climate and then transfers all the data sets to HLRS, and KTH does something else, and I think this won't be possible anymore. We already have currently reached, let's say, the limits of data shifting, data movement, etc. So at the end, personally, and I like the Japanese way of doing this because they stop talking about the EXA, but they're just talking about the post-petascale. Yeah. And currently I try to avoid the EXA scale approach. I just talk about EXA because it's much more easier to interpret. But I think in this community, we probably should look also at this kind of combination of different simulations, which themselves grow up to a size which needs these big systems of millions of cores running there, let's say, of having an internal quick network. And I think we should be clear about this, not try to force ourselves to provide now within 2 years an EXA application, which is not possible, let's say, with the funding that people have. To be honest, you need a lot of manpower to do this, you need a lot of experience, you need a lot of, let's say, other things. And at the same time, there will be a changing ecosystem in terms of, let's say, new algorithms, new approaches, etc. And personally, I think if we go that direction, I think we are much more on a path to success than trying to force ourselves into this EXA scale, let's say, I wouldn't say curse, by any means.
Do we have anybody who would like to contribute such an example that Bastian was speaking about, of combining? Like in epidemiology, do you see potential for combining with some sort of other model from the more traditional classical HPC world, or I don't know, in whatever other application?
So I think the points he's made are good ones, and I can at least give you a couple of examples. In epidemiology, just understanding the spread of diseases is only one part of the story. If you look at vector-borne diseases, for instance, and I think folks here have studied, we have studied Zika now, weather has a big role in it. Environment has a big role in it. And when I say environment, you have the vectors, you have the humidity, the canopy, the vegetation, all of it plays a big role in the simulations. And then the part that we often don't talk about here, and we never get a chance, is the whole logistic framework that supports thing. If it is only understanding the spread of diseases, that would be one thing, but we are really talking about individual behavioral changes and the supply chain that goes into the system, supply for vaccinations and antivirals and treatment units and face masks. So one of the big studies that we did with DoD was precisely how to move supplies to rural areas if there was a big pandemic. So the point is, even in an application that looks so health related, we already have at least 3 or 4 different layers of simulations that are being worked out. And your point is well taken in that you're not running one big molecular dynamics code on 1 million processors. In fact, the workflows are making this interesting, and you have a lot of patches of the system. So in another white paper, we have articulated this aspect. But I think it goes even beyond that. We think that for understanding a public health problem, single run doesn't make a sense. We've already talked from Eva, about uncertainty, so stochastic runs, and I think Alessandro mentioned it too. But it's more than that. It's usually what I call a design of experiments. It's a sequential design of experiments that is really the unit of computation, not a single run. So you have multiple replicates in a cell and lots of cells, which is either static design or a sequential design, because you're actually going forward with the outcomes in a Markov decision process style thing. So maybe I'll stop and let Rob speak a few things, because I'm sure he has.
Okay, I just wanted to mention that it might behoove us to just take a longer view and just be sure we're cognizant of the longer view, that think about, what kind of needs will we really want to exercise, say by 2025 or something. And so all this tactics and strategy associated with making networks first-class objects, I support all that, and that's all fine. I will report on that particular one that my team once built a system where we tried to make the environment a first-class object, and then it turns out when networks came along, it was not easy to morph that code into something. So I do worry that making networks first-class objects are problematical, but for now it's important to do that. But I was going to say that I think that, for example, think about exascale computing. I mean, we really need to think, I personally think we need to go out to the next level for social science problems, because, look, ultimately what we're going to want to have is, we're going to want to have a SOAR or ACTAR type cognitive infrastructure for each agent. And so today we can't do that. So today we have very trivial agents. Think about much of the progress with modeling human behavior has gone from relaxing the rational agent specification, which involves some calculus, and you could do it on the back of an envelope, right? The stuff we learned in graduate school, to basically having some richer representation of behavior. And of course, arguably, that's one of the weaknesses of the current class of epidemiology models is that they don't have much behavior representation. Somebody gets sick, but they're still doing the same thing they were doing before, or there's a very small. What about people who get sick or what about people who are healthy? They see on the, we have a model where they see in the media that there's an epidemic possibly happening. They're hypochondriac. They go to the hospital and they get sick at the hospital because that's where all the sick people are. I mean, we need to model those behavioral things in order to really understand it. But I mention it only because, think about the Nobel Prize in economics has just gone for behavioral economics. What is the current status of behavioral representation in economics, or just broadly speaking? We know there are 100, 200 behavioral anomalies, which that's just economic speak for the way humans really behave. We call anomalies. So that's weird, right? There are 150 departures from rational behavior that are well understood and reproducible in a laboratory setting. I don't have a representation of those I can put on a machine today. I want that. I want to have models. If I want to do finance models, let's face it, all the finance models we talked about in this meeting, they're all really 0th generation, 1st generation, because they don't have anything behavioral in there. They don't have things like people jumping out the window when their portfolio falls in half, right? It's got to have that. That's what really happens, right? So think now about social science modeling, where you have a deep representation of cognition. Only way we know how to do that today is with ACTAR, SOAR, or Clarion. I'm just mentioning 3 well-known systems. Each one of those systems is going to involve on the order of 10 megabytes of cognitive architecture. So I'm going to have 10 megabytes, and I want to do 100 million actors. Okay, I just swamped every existing HPC. I just took the entire Bridges site at Pittsburgh Supercomputing Center, and I'm using all of it. And I still can't make runs within less than a week or something. So I really think that makes sense to. If you think out to 2025, 2030, or here's a different way to say it: is that whatever hardware we can imagine today, we can easily saturate it immediately, and that's just Here's the other opposite way to say that is, giving existing hardware that is available to us in supercomputing centers, we all have to scale back our aspirations radically in order to do what we do, and we basically put up bullshit models because that's all we can do. But you can really imagine wanting to do a lot more if you had it. And then of course all of our friends in neuroscience say, you're trying to model the brain with a megabyte? That's ridiculous, right? For example, so a famous physicist recently told me, I won't mention it. Are we recording this? We probably are, right? I won't mention the name. A world-class physicist recently told me, he said social science is impossible until we solve neuroscience. And he was deadly serious. He was saying, he said, you guys are alchemists until we have a good neuroscience model. And this is a guy with basically it's essentially a Nobel Prize. So anyways, I just report the fact that I think we really need to be thinking, exascale and beyond in order to really have leverage on social science problems.
Well, I just have a question, but I want to motivate it. Bastian said that these communities evolve, and I think it's quite important not to try to live in yesterday's community. And one of the beautiful things for me about this particular meeting is to have guys like you here. So we have this conversation between you guys in America, us in Europe. There are connections, and I understand you are also involved in them, with some people in China, and that's also beautiful, and that's nice. We had Sanzio Bassini here yesterday from the Marconi world and this stuff. I wonder, I understand that the Chinese are going to build their first exascale machine in Shandong province. For those who don't have the map of China in mind, it's roughly speaking a bit south of Beijing, not very far. As far as I understand, in the US, the first machine will be in Argonne, Illinois, and then some Californians will join in and stuff. Does anybody have a sense of where the first exascale machine could be in Europe? Switzerland just joined the European HPC initiative, and Pitzstein is quite an impressive machine. There is a certain universe there. I cannot imagine that Switzerland would be the place where the European Union want to place its first exascale machine for obvious reasons. Although as a Swiss citizen I would be proud to have it. But does anybody have a sense of where the first, he seems to know?
Okay, so I can, let's say, start with the excluding factor, which will be done in Stuttgart, because we don't want it. Now we have a production system always running at Stuttgart, and to be honest, the maintenance cost, operation cost, it's nice we donated to somebody else to have this machine. I think what you say is an indirect, let's say, interesting point, because the decision in US, the decision in Japan, the decision in China is taken by the government at a certain point in time, the fund, or let's say by those persons giving the money. In Europe, it's like it can be in 26, 27 member states, we are not sure. Might be that Romania builds up a new infrastructure to have the system because it's of a political reason correct. I don't know. I think there are candidates, I'm not saying it won't be in Germany, to be honest. I think there are some countries which have the experience to run a system. To be honest, at the end, the first exascale system, and Europe will have a different approach to this because there will be 3 exascale demonstrators. This is the plan, to have them at 2019, 2020 time frame, or 2020, 2021. It's always up for discussion. It's a bit like the Intel roadmap. It changes hourly, let's say, the time plan for doing this. But Europe wants to have these exascale demonstrators. They have not decided where to put in. I think people will apply for this, and at the end, it depends on the member states who will give the money in. For the German part, I can say this because it was officially announced. There will be, for now, they plan an own German EXA strategy, because there was a certain meeting where there was an offer for Germany to pay, I think, 90% of the money, and then it will be somewhere in Europe. This offer, they are still discussing about this, let's say it that way. On the other hand, to be honest, as long as the machine is accessible for others, for people outside, it doesn't matter where it stands. It will be a prestige thing. People want to have, let's say, this political impact. I can just say, I think, quite clearly that it won't be in Stuttgart.
If I may just follow up, I completely agree with your analysis about the difference in decision making. Still, I think it's obvious that the country with the strongest political interest, not necessarily the biggest pocket, but the strongest political interest in all this is France. And this ties in with the existence of Airbus and, let's say, another political industrial complex that I don't want to describe in detail. And for sure, the Macron crowd will want exascale to be, in a very important sense, not under control of, but very, very well accessible from France. We will see. I just believe it's useful to have conversations like with Sanzio yesterday, with the Pitzstein people. They're hiring exascale people right now in Switzerland. I'm sure they don't have the plan to be the first to have such a machine, but there will be such a machine in Switzerland sooner or later. But I'm interested in getting more contact, and I have some, with the people in France, and there's more out there. Romania, well, I would be a bit surprised. Norbert, please.
About the Euro HPC program, yeah, which will, which already start in terms of a concept, yeah, and will later on be founded by the European Commission in course in 2020 and after, so framework program 9. I agree with Bastian so far. If we don't know the rules, I mean, if the member countries so far they will not know the rules, they will not decide where the exascale system will be located. I think that's clear. But last time we had also a discussion in Prague. There was a representative from the European Commission. At least for now, it is not allowed in Euro HPC that the system will be located in associate countries. Yeah, so Switzerland is at this moment unfortunately out. Yeah, but that's the current state. But so far, as I said, we don't have any regulations in Euro HPC. Yeah, that's just the beginning. Yeah. But I agree also, Switzerland is a very good country, I would say neutral and so on, yeah, but yeah, Let us see. But much more important for Europe and for the site or country which will found this system, because a significant amount of money should come from the member country or countries, yeah, because it will be a joint effort. It's the solution, yeah. So we are still looking for really exascale applications, yeah, because there are some candidates, yeah, and staffs or groups which are saying that in terms of, for example, climate simulations or weather simulations or human brain project, these are the candidates for exascale, yeah. But I'm quite sure if we say right now, yeah, that let us really scale the existing applications, we will not be able to make an exascale application. Yeah, it requires tuning and also changing the approach and changing the algorithm. Yeah, the current existing algorithms are not able to really to scale to thousands or hundreds of thousands processes. Yeah, it's not possible for the moment. We have to take also into account that when we scale the application, the application should be also somehow work in a reliable way. Yeah, so having hundreds of thousands on CPUs, we can be quite sure that some of them will break, yeah, during the operation, and that cannot cause the break of the application. That's something what we are not ready right now.
I'm taking two last comments because then we want to move on to the big data session. There's Javi. Anybody else after Javi?
Okay. I'm Francisco Javier Nieto from Atos. So as probably you all know, I will say that Atos is the main provider of machines for HPC systems in Europe. So there is an aspect that has not been commented before, which is related also to the industry itself when we are talking about exascale systems, that in the end, there is a very strong interest in France because Atos is a French company, actually. And we are expected to be one of the main providers of exascale systems from the European perspective. Actually, I would say that probably the European government expects that we will be the only European provider able to do this. I can tell you that from the European HPC perspective, we have been requested from the Spanish and the French government to Atos to really be active and to participate in the research actions related to not only building exascale systems, but also this effort which has been, or which is in progress related to the design of the new European processor, you know. So we are talking about new CPUs that will be part of these Atos systems and expected to be widely used in exascale systems. So there is also this industrial aspect that has to be taken into account because if we are not able to do this, Europe will have an issue in this part of the selling systems ready for exascale, and our only option will be to adopt systems which are not European, from the US, from China, I don't know. But I mean, it's something that we need to take into account because this is a very strong political reason as well.
Can I just make one point, Sarah, because it's useful. I think Robert made a point about computation not being enough, and I think it's a good point. So the models have to work progressively to take into account the limitations. I view it as a constraint programming problem. And just as a quote, I attended a meeting and I found this very, very nice number to remember. It's, as I understand it, the current Apple iPhone has the same computing power that the Reagan government had in the Pentagon that time. Okay, so the point being that if things go the way it is planned, the reason to work on these systems is, of course, one, it's interesting, but if the trend continues, then you get machines that become smaller and smaller. Now, how far this goes is a question that is debatable. I cannot predict this, but there's something to remember. That was one point to speak to the whole thing of why we should continue to push these systems in that direction. Also, I think you folks made a good point about exascale systems. They're going to be extremely heterogeneous. This concept of a homogeneous system is not going to work in exascale. You'll have FPGAs, we'll have GPUs, we'll have neuromorphic parts to it. And the system itself is going to have so many different ways of computing, which is going to make it challenging. And my last comment to Rob was, I think the point of cognitive system is well taken, but already in epidemiology, we're also working on building immune system models and that's as large. So as we start going what we call within, so the term we've been using is within skin and outside skin. The within skin part is immune system modeling, metabolic pathways modeling, the drift and shift in the virus itself, because that affects, and then of course the behavioral model. So this, I think we all can be rest assured for job for at least in our lifetimes, at least for the folks sitting here. This is not going to go away anytime soon. So I just thought I'll end with that system.
Thank you. And thanks everybody for your contributions. I think this session has been a very nice little look into the future on the different aspects of the future of HPC, the future of the computing being done by everybody's cell phone in their pockets while walking around and meeting with some, and in parallel other small groups meeting somewhere else. And the future of social science modeling, where maybe one day we will have these agents in the systems being more and more human-like, artificial intelligence, at least intelligence. So one of the aspects in the session was also that the social science computing is very data intensive, so I think it's a good point now to move on to the big data session. I will excuse myself for going to training and want to ask Leo to come up here to moderate this session.